Okay, welcome to class. This is primary 4, and we are going to look at the topic called dimensional geometry, where we look at shapes, geometrical tools, and all that. So for today, we look at dimensional geometry, where we're going to look at shapes with dimensions. Majorly it's measurements. Note, plane shapes have one face. A plane shape, as we are going to be looking at them, they have only one shape. All four-sided polygons are called quadrilaterals. For any shape which has 4 sides is called a quadrilateral. So that's their special name, and we can have examples of quadrilaterals. We can have number 1. The common one is a rectangle. We have a square. We have a kite. We have this one, it's called a rhombus. As we go on, we shall be looking at their properties as we go on other classes. We can have a parallelogram, which also has 4 sides, and so many others. So any 4-sided polygon is called a quadrilateral. Now, we are going to look at how we can accurately draw a rectangle. So let's start with drawing a rectangle, but we are going to start with, because these shapes are made up of lines. So we shall start with line segments, and then we go into the rectangle when time comes. So drawing a line segment of 6 centimeters. How do we draw a line segment? Because these shapes that we are going to look at come from lines. So we can start by constructing a line segment of 6 centimeters, and there we shall need a ruler, and then a compass. But meanwhile, we can as well construct or draw without a compass by just drawing a line that we can call a baseline. When we draw that baseline, we can put a mark. And from there, on our ruler, we have 0. And we are going to use centimeters, and you can see this is centimeters. And 0, where there's this first mark, that's where we have our first, or the starting point. So when we put our mark, the first one that we have put here on the compass, on the line, just because our line here is, the body is very small, but we can say, if we counted 0, 1, 2, 3, 4, 5, and 6, and then we mark and say it is here. Then we can say this is A, and where this point is B, where we counted 6, and then we shall write here 6 centimeters. That's the line segment of 6 centimeters. Now, if we are to use a compass, if we are to use a pair of compasses, we are going to put our starting point here. This line is PQ. Let's put P there. And we shall get our compass and put our pencil there. And we shall put this sharp point of the compass, that needle, the one that can prick you, and put it in 0 and stretch the compass up to 4 centimeters. Up to 4 centimeters. Then you bring the compass here and put it at the starting point, and then make that one there. So this point will be Q, and this is now 4 centimeters. So that's basically how we draw or construct line segments. The next part here is drawing an angle of 90. Drawing means we are not going to use a pair of compasses. We are just going to draw using a ruler and then a protractor. This one is called a protractor, whereby the units here are degrees. So we have 0 here and then 0. It has two scales, the inner scale and the outer scale. So we have an example here using a pencil, and for my case I have my pencil is here, a ruler, which is this one, and a protractor. Draw an angle of 90 degrees. Of 90 degrees. So we are going to say, we are going to draw a line here down, which will act as a baseline, where we base to draw an angle of 90 degrees. 90 degrees. We are going to look first of all at this angle, and then we shall look at our body parts that can form angle 90 degrees. Now, this is our starting point. Because we are going to draw, we shall not use a pair of compasses, we are going to use a protractor. So we are going to mark this point, where on your compass there is that middle point. That middle point there, you put it at this line that you've drawn. Mine is there properly. And make sure that transparent line on your protractor is exactly on the line you have drawn using a very sharp pencil. So now, mine is here. I'm going to start counting, not until I get the angle of 90 degrees. So I'll start from here and say 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. And then I put a point there. And then I get my ruler and then join that point and the starting point that I have drawn. So you see, and then I'll put there the symbol of 90 degrees. So this one is 90 degrees. Let me put it this side because we counted from the left. So this is 90 degrees. 90 degrees. The degree, the symbol for degrees is just a small kind of 0 up there on that figure. So that's an angle of 90 degrees. If you are to draw it on the right, you can as well put a baseline, put a starting point there like that, and then still go to where our point is, the middle point of our compass. Make sure the transparent line on your protractor, that line down there, is exactly on the line you have drawn. Now like mine here, so I want my angle of 90 to be on the right hand side. So I'll start 0, 10, 20, 30, 40, 50, 60, 70, 80, and finally 90. So having put that point, I'll come and join this point that I've marked and the starting point here, and then I'll join. Because I've counted from the right, I'll say my angle of 90 is that side, 90 degrees. So that's how we draw angles of 90 using a protractor, a ruler, and then a pencil. So now, I've told you that when we started here, we looked at these quadrilaterals, four-sided polygons, the figures, and then we say that this one is the common one here, the most common one. And we are going to see how we can draw a rectangle. Of course, having learned how to draw line segments, because these figures, these polygons, these shapes, we can join line segments to come up with one of them. Now we have an example here, drawing a rectangle. With the help of a ruler is here, a pencil is here, and then a protractor. All our instruments are now here that we have to use. Draw a rectangle ABCD, where AB equals to 8 centimeters, BC equals to 6 centimeters. Centimeters, we get them from the ruler. And when we are going to draw, we have what we call a sketch. A sketch will guide us on how to draw an accurate rectangle. So the first one here we have to put, we learned how to make line segments. You see, that's a line segment. Now we say AB, we've been told that is 8 centimeters. A rectangle has two opposite sides equal. So now we can put as well BC. Because B is here, so C will be up here. So that is now 60 centimeters. automatically D is going to come at that point there. So it will be somewhere there. And then we join up. All those are line segments that have formed a rectangle. So a rectangle, the two opposite sides are equal. This side is equal to this one. And then also this side is equal to this one here. So this is also 6 centimeters. This is also 8 centimeters. And this is point D. Because we've been told that rectangle A, B, C, D. Now let's see how we can construct. how we can draw. We are going to draw, not constructing, because construction will require a compass. But this time the instruction is draw. We are going to draw a rectangle whereby AB will be 8 centimeters. And that's our baseline where we have to start from. So we put a starting point. And that starting point, this rectangle here, these angles here, they should be 90 degrees, 90 degrees, 90 degrees. So now at this point, which I can say is point A, I'm going to draw there an angle of 90 degrees. I'll say 90. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So I will have to draw there an angle of 90 degrees, and then I'll not mark anything up there other than I'll just put the angle of 90, the symbol of 90 there. Then, where is point B? Point B has to be at 8 centimeters. So using my ruler, I have to find where we have 8 centimeters. So you get the starting point, the 0, at this point, and then put your ruler there, like mine now. Having put it there, come and count. You see on your ruler, there is 0, 1, 2, 3, 4, 5, 6, 7, and 8. Finally, 8 is there. I'll make a mark there. That's mark 8. 8 centimeters is at this point, and that's now point B. And this one has to be 8 centimeters. But when you look at our sketch that I told that is the one that has to guide us on drawing an actual rectangle, it is showing us that at point B still, we have to put there an angle of 90 degrees. Now, this angle of 90 degrees has to come from the left. So we shall remember how to draw the angle of 90. So don't put the protractor like this and then put 90 here. No. I told you the transparent line on your protractor should be exactly on that line that you have drawn. So now this one is 0, 10, 20, 30, 40, 50, 60, 70, 80, and finally 90. So our 90 degrees is here. Our 90 degrees is there exactly now. So I'll put a symbol of 90 degrees there. So now what are we remaining with is to indicate where 6 is, and then C and D. So now get your ruler and that point where there is a 0, there is first mark, and put it on your at point B on that side, on that line that you have drawn. So then you'll count 0, 1, 2, 3, 4, 5, 6. My 6 is there. My 6 is exactly there. So I'll say this is point C, and this is 60 centimeters. And then I'll also come this side and count 6. So here we had 6. Also here I have to come and count 6. So 0, 1, 2, 3, 4, 5, 6. So 6 is there. Then I'll know this is point D, and then I have to come and join them. So you see that this one is also 90, that is also 90. This side is 6 centimeters. This one is equal to this one, it's also 8 centimeters. You can as well use the ruler and check and see if this is 8, and also DC is also 8. So that's basically how we can draw a rectangle using a ruler, a protractor, and then a pencil. So other levels we shall be constructing rectangles using the protractor when you see me in the next video. So now we have learned how to draw a rectangle. So we are going to look at another quadrilateral, which is a square. A square is very interesting. Very interesting. One, it has all sides equal. And then the other point is, it has angles of 90 degrees inside it. So I even told that we are going to use our bodies to see where do we have an angle of 90. When you do your hand like this is an angle of 90. When you do this hand, it's an angle of 90. When you do your leg like this, an angle of 90. When you bend, that's an angle of 90. So an angle of 90 is part of our body. So now let's see how we can draw a square. Drawing a square. Using a ruler, a pencil, and a protractor, draw a square. PQRS of sides 4 centimeters. Of course, before we draw an accurate square, we are going to have a sketch. What are the properties of a square? The first one is all sides are equal. All sides of a square are equal. So if this is PQ, and this one now will be R. So this is a sketch. Also here will be 90. Come here will be 90. And then you join up there. It also will be having 90 degrees. So this side is equal to that one. They are all equal. And if this is 4 centimeters, even this is 4 centimeters, even this side is 4 centimeters, even this side is 4 centimeters. Look around your house, your room, or the classroom and see where do you have objects which are in a square form. Is it your book, your bed, or something else, a box? So check them. So then let's see how we can draw an accurate square of sides 4 centimeters. First thing is, let's draw a baseline. That baseline you shouldn't measure, just draw it. And after drawing that baseline, we are going to mark a point, the starting point here, and we shall have to put there an angle of 90 degrees. An angle of 90 degrees. Now, we remember that we have to use a protractor when we are making or drawing angles of 90. And don't just put a protractor like this and say that 90 degrees is there. No. Remember, the transparent line on your ruler, there is a line, a black line. Make sure it is exactly on this baseline that you have drawn. So we are going to put a protractor here and make sure that point is exactly that point you have put. And then because we want our 90 degrees inside the square, we are going to count from the right hand side. So 0 is here. 10, 20, 30, 40, 50, 60, 70, 80, 90. So we mark 90 degrees there. We get our ruler and then we come and draw the angle of 90. And we have to show that point. So that is point P. Now, we have to look at PQ. PQ is supposed to be 4 centimeters. So get your ruler and from the starting point and put it at point P. Point P, and then we get the 4 centimeters. So we shall say this is 0, 1, 2, 3, 4. And we shall mark there. This one is point Q. Point Q, and this is 4 centimeters. And now, at that point Q, when you look at our square, we should put that angle of 90 degrees. Remember to get a protractor and put it properly and make sure you count off 90 degrees from your left because it's inside here. Don't count from this one again, you put it outside. No, have to count it from here, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. And our 90 is there. So now we have to join and make this point. We have to make sure that it is exactly there. And having put the angle of 90, we have to put the symbol of 90 degrees. And then our accurate square is not complete. We are remaining with other sides, QS and then PR. Where should we put point S? Should we just put it here? No. Should we put R here or there? No. We have to measure. We have to get the 4 centimeters. We have to get the 4 centimeters. And then remember this. If you see that the lines you have drawn are shorter than where you have to mark, you can as well prolong it. Prolong the lines to see that you have an accurate drawing. So now I'll put my ruler at that point, the starting point, and then I count 0, 1, 2, 3, 4. My 4 centimeters are here. I can even say this is point S. But now when I come this side, do I have 4 centimeters on that line? Line is going beyond. So that's what I've said, that you have to add just in case you see that your point will be hanging in space. So you adjust, but you don't need to make that work. You just draw a line once, like mine. You draw it once. But if you had written the word accurate using a pen, don't trouble. You just draw, and the word marking will mark it correct. So now, this is, we have to come and say 0, 1, 2, 3, 4. We have our point there, 4 centimeters. And now this is point R. But we cannot just leave it like this open. No, we have to close it. So we have to draw a line there, and we connect those 2 points and say, so this is RS, it's also 4 centimeters, this is 4 centimeters, and also this is 4 centimeters. See, all these sides are equal, this angle is 90, and that one is also 90 degrees. So now this is how we draw a square. You can do this over and over again to make sure that you do enough practice and have actual drawing of a square, of the rectangle, angle 90 degrees, and even these line segments using the tools that you have been given. So now we are going to look at another point, having learned how to draw the line segments, the angles of 90, the rectangles, and the square. And now here we are going to look at finding perimeter of shapes, those shapes that we've been drawing. Perimeter basically means the distance around a figure or any polygon, any shape, anything that you can as well find this distance around. If it's this ruler here, if you've been asked to find the perimeter of this ruler, you add this distance, add on this one here, and then finally there. From the starting point to the starting point. That's how we can as well define perimeter. So now we are going to look at 2 ways of finding perimeter. One is by counting. Find the perimeter by counting. And this one is not going to be very, very hard. I told you last time that mathematics is the simplest subject. So look here. How do we count and see that the distance around this shape we've been drawn, given? So are we going to count these boxes? No. Perimeter is distance around a shape. The distance around. So if this is our starting point, and we have to move and get back. We start from here and get back there. So we can say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So our perimeter is 14 units. We can even do this in another way. We can say 1, 2, 3. We write a 3 there. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And where you end, that's our perimeter, 14 units. Just right there, 14 units, and then you get a very long tick. Now we look at this other way of finding perimeter, whereby we've been given measurements. Find the perimeter of Roman 1. We have, this is a rectangle that we've just been drawing. This side is 8 meters, and this way is 4 meters. But we have to know that perimeter is distance around a polygon. So we have to add this 8 plus that 4. If we end there, that is not perimeter, because this side is missing and this one here. So we have to make sure that we add 8 plus 4. Now we have to get this one here. But according to the properties of a rectangle, this side is exactly equal to this one. So if this is 8, also this is 8 meters. And this side is equal to this one here. If this is 4 meters, also this is 4 meters. Remember, perimeter is the distance around a polygon. Now we are going to say, we can as well say, when we are, the special name for these sides, we call this one length. This is called length, and this one is called width. Now, we can say length, we can shorten it and say L, and we can shorten this one and say W. So we can say length plus width plus length plus width. So remember, this is the starting point, plus width. So don't say length plus width plus length plus width plus again length. No, they are basically 4 sides, and make sure you have 4. This is 1, 2, 3, 4. 1, 2, 3, 4. Now, where is length? We have 80 meters plus width. We have 4 meters plus this other length. It is 80 meters plus this other width. It is 4 meters. Now we can as well count and see what is 80 meters plus 4 meters. Now I have not written the word meters. Now someone is saying, hey teacher, are they meters? Yes. Now we use other words. Now we can now say 80 monkeys plus 4 monkeys. That one looks very interesting, but these are meters. So 8 plus 4, you can have 8 and say now 9, 10, 11, 12. 12, so this is 8 plus 4 is 12 meters there now. And then 8 plus 4, so we can have 12 meters. Now, what is 12 meters plus 12 meters? The answer is very simple. You can as well look here and say 12 plus 12. 2 plus 2, 1, 2, 1, 2. This is 4. And then 1 plus 1 is 2. So that is basically 24. So this is our perimeter for that rectangle is 24 meters. Perimeter equals 24 meters. We drew a rectangle, and then another shape was a square. So let's also look at the perimeter of this square. Now look here, it is not serving only this. But when you look at these symbols here, they are showing us that all sides are equal. So if this side is 3 centimeters, also here is 3 centimeters, here 3 centimeters, here 3 centimeters. Now someone will ask, is it also having length, width, and width, and yes? Yeah, it is also, but we can as well say that this is a spacer shape, whereby all the sides are equal. And then we are not going to say length plus width plus length. We can just say side 1 plus side 2 plus side 3 plus side 4. Because I told you that there are 4 sides. Now, side 1, we can say this is side 1, side 2, side 3, side 4. So this is 3 centimeters, side 1, and then plus 3 centimeters, plus 3 centimeters, plus 3 centimeters. And our answer is good. It is 12 centimeters. That is perimeter of this square. Another way we can find the perimeter of this one, because all the sides are equal, we can simply say, just look here briefly, we can simply say that perimeter of a square equals to 4 sides, 4s, whereby this one comes from 4 times s. Why? Because side plus side plus side plus side, we get 4 sides. And now when we say 4s, we shall write that one as 4 times s, which is 4 times 3 centimeters, which will give us, what's 4 times 3? 10, 11, 12. So we shall have 12 centimeters. So if this method is very hard, you can use this one. If this one is very hard, you can use this one. But to me, they are all very simple. Okay, so that is perimeter. I thought that perimeter means the distance around a figure. All figures. That's how we find the perimeter. We can just add all the sides around it. And then when we go to finding area of shapes, areas that space covered by a plane or a polygon, anything, that area which has been, that part space covered is what we refer to as area. Now we have also 2 ways of finding area here. One is by counting squares, and then 2 is by calculating. So we have an example here, find the area by counting. So this one is simple. You can say 1, you can write there so that we don't forget. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We can write and say the area for that shape is 15 square units. This SQ is standing for the word square, because we look at that we are going to be multiplying, and multiplying something of the same kind, it will be squared. So we are going to say this is the area of this shape is 15 square units. You just abbreviate the word square by writing SQ. Now we can say work out the area of this polygon here. Of this polygon. So we can say area of a rectangle. You know, remember, a rectangle has those 4 right angles, and this side is called length. Its special name is length, and the special name for this side is width. When you look at this first example, we counted 1, 2, 3, 4, 5. Those are 5. This side we have 1, 2, 3, 3. How did we get 15? It's just 5 times 3, you can get to 15. Meaning our area here for this rectangle, we can say the length times width. That is L times W. Basically. So we are going to say, what is the length? By the way, don't say length, because here we said length plus width plus length plus width, and then you also come and say length times width. No. We only multiply 2 sides, the length and the width. When you multiply here and there, you will be having the whole of this space covered. So our length is 6 centimeters and the width is 3 centimeters. Now, how do we multiply this? And we are going to say 6 times 3, those are 6 groups, each group having 3 members. 1, 2, 3, 4, 5, 6. Each group having 3 members. This is how we can simply multiply. So that things are very, very easy for us. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 6 times 3, or 6 multiplied by 3, the answer will be 18. Now, what is now centimeters times centimeters? That's when we are going to have, because here these were units, that's why we put square units. And now here, because we are multiplying, we are not centimeters, we are not going to say square units. No. Because these units, we didn't know them, but here we know the units are centimeters. So we are going to say square centimeters. Square centimeters. So the area of this rectangle is 18 square centimeters. So this is for the rectangle, good. And this one is for the square. This shape is a square because all sides are equal. And this formula also is also very unique. And let's look at it. So because in perimeter we had side plus side plus side plus side. That is distance around. That's why we are adding. But when you are finding area, we have to multiply only two sides, only that side and that side. And now this is a side and also that is a side. Side and side. So we are going to say side times side. Simple. Not 5 times 5. Let's write it like this. Side times side. And because each side now for this case is 4 meters, we are going to say 4 meters times 4 meters. What is now 4 times 4? The answer is good. It is 16. And then meter times meter, we are going to have square meters. So the area of this square, whose side is 4 meters, is 16 square meters. So whenever you are finding, when you have been given find area, make sure you multiply. If it's for a square, it is side times side. Only two sides are multiplied. And then for a rectangle, it is length times width. And then if you are finding perimeter, you remember to have added all the sides that you've been given. Good. So let's look at another topic. Interpretation of graphs and data. Data. This one data here. Not data for the ones that your parents, your brothers, your sisters, aunties and uncles put on their phones for WhatsApp and the Facebook. This is data like information given. So graphs, we have so many types of graphs. When we've been given information, we can as well represent it on different graphs. One of them is a line graph. We shall look at it. We have a bar graph. We have a circle graph, the one we can call a pie chart. We have a histogram and so many others. But now we are going to start by looking at tallies. A tally is a symbol basically used to represent any number given. So just a symbol, and that symbol is drawn in a very unique way. It's not drawn like number 1, no. It's drawn when it is somehow slanting. So this is the symbol for tally, not this one here. It is this one here, the symbol we use when we are drawing tallies for given numbers. So we can as well look at our number here. We have an example. Below were ages recorded in primary 4 class. We had some children. One was 8, one was 9 years, 10 years, also 8 years, 9 years, 8 years, 10 years, 8 years, 8 years, 10 years. Then the question is telling us, draw tallies for each age group. So now, we are going to look at 8. If we have 8 there, how do we have to draw the tallies for age group 8? First of all, how many age groups do we have here? We have 8, we have 9, we have 10, do we have 11? No. So those are the age groups that we have. So we have the age group of 8, and we want to find how many pupils were 8 years. So we shall come to our data here, the information we have. we have the first child here, that is 1, 2, 3, 4, and now the fifth one, we are not going to put 5 like that. We are not going to put like that, we shall tie it here. So that is, how many were they? They were 5. So we come to age group 9, we shall come here and say, that is 1, we put the tally, 2, we have only 2 pupils who were 9 years, so we shall put 2 pupils. And then how many were 10? We have 1, 2, and 3. So those were 3. So if there are 3, not until we reach 5, that's when we can tie one like this. But if they are before we reach 5, if they are 4, just say 1, 2, 3, 4. If they are 2, 1, 2, just like we've done it here. And then we don't put any other. So that is basically how we draw the tallies for the numbers. Now we can have this number 2. Which number has been represented? We've been given tallies here. So we can as well just count and say, every band that we are seeing here, we have 1, 2, 3, 4, 5. That is 5 plus 1, 2, 3, 4, 5. And then plus 1, 2, 3. So what is 5 plus 5? 5 plus 5 is 10. 10 plus 3, 11, 12, 13. So the number whose tallies has been represented is 13. So this is 5 plus 5 and plus 3, get 13. So now if we've been given represent 8 using tallies, this is when we are going to divide. So to get the bundles, we are going to say our answer here, the solution. So we shall say 8 divided by 5. 8 divided by 5, if we have 8 sweets, and we are going to give them to 5 girls, everyone will say 1, 2, 3, 4, 5, 6, 7, 8. So we have to share equally and say every girl has 1 sweet. So we are going to say it is 1 remainder 3. So because we have 1, this one we are going to represent it by drawing a bundle of 5. So we are going to say 1, 2, 3, 4, 5, and then the remainder 1, 2, 3. So one bundle, or you can say one group of 5s and then the 3 1s. So that's basically how we draw tallies for a number. And here, if we've been given this number, you just keep on, this is 5 plus 5 plus 3, and then you get the answer. So then here, it is, you have to divide by 5. Why? Because all these ones are typed in 5s. We count them in 5. So that's what. Let's look at a histogram. A histogram looks like a bar graph, but for it, its bars are joined, as we are going to look at that. So representing data, this word data can mean information that has been given on a histogram. This word is histogram. Now we have an example here. The table below shows the number of sweets. The table below shows the number of sweets collected by a canteen attendant at Train Up at Charlie Primary School in 5 days. So here we have day and then number of sweets. Monday, this canteen attendant collected 10. Tuesday, 5. Wednesday, 15. Thursday, 30. And Friday, 20. The question is, show the above data on a histogram. So we have our solution here. And before that, we have to choose the scale. The scale is normally put on the vertical axis or the vertical side of the histogram. For the horizontal part, we don't need to get a scale. Why? Because these ones are not standard. But here where we put our numbers, we have to find a scale. And how do we find a scale? Because of these numbers that we've been given, we shall look at them and we get at least the simplest factor that we can as well use. Now here, we shall draw and put Monday, Tuesday, Wednesday, Thursday, Friday. These are days of the week. and then this side we can choose and say, one small square will be representing 5 sweets. So now we can put our 0 here, and then 5, 10, 15, 20, 25, 30, 35. We shouldn't need to come and say 5, 10, 15, 20, and then 35 or 30. No, we have to go with this order. As we count in the 5s, if our scale is representing 5, we have to go in the 5s. 5, 10, 15, 20, 25, 30, 35. Now, we are going to look at, on Monday, how many sweets did this continent collect? On Monday, how many? They were 10. So we have to come and say, where is 10? This is 5, 10. So we have to shade properly. On Monday, this attendant collected 10 sweets. And then on Tuesday, we have to shade properly there like that. And then on Wednesday, we come on our given data. Wednesday we have 15. So we have to come and say 5, 10, 15. And we have to move until we find that day of Wednesday. So we have to shade properly here. Make sure as you are shading, your lines don't cross to another day, because you are basically looking at that particular day, Wednesday. And then on Thursday, we have a very big number of sweets. That is 30. So we come here and say 0, 5, 10, 15, 20, 25, 30. And then we can use our ruler and say, oh, that day we have to move like this until we find our next day. We can put a mark there, and then we start shading. We shade using a pencil and a ruler properly like that. Remember, I told you there should be no lines crossing to another day. That is Thursday. And then on Friday, we have 20. So we come here and say 0, 5, 10, 15, 20. We can put a ruler until we find our Friday. We put a mark, and then we start shading. So when we finish shading like that, we shall be having a histogram. I've told you it has bars but which are joined. This is not a bar graph, but it's a histogram. A bar graph, they would be separated. There would be different bars representing information. So you can as well find a bar graph, a histogram like this one, or a bar graph when it has been given to you, not a histogram, and then you can be given so many questions, and like on which day did the canteen attendant collect the least number of sweets? That is Tuesday, the smallest number of sweets. On which day did the attendant collect the highest number of sweets? That would be a Thursday. So when you are given such questions, you just come on the histogram and then start reading the information from there. So now we have a pictograph. Remember, I told you we have so many different graphs where we can represent data. A histogram has been number one that we've looked at here. And then we have a pictograph. The word pictograph can be coming from the word pictures. Picture graph. So this is a pictograph where we have pictures, and I'm very sure you've seen these ones very many times. So we have an example here. If one picture here of a ball is representing or represents 6 balls, how many balls are in? We have 1, 2, 3 pictures. So we have to come and say, one picture of a ball is representing 6 balls. How about the 3 pictures? We know that each one has 6 in it. 6. So we can just simply come here and say 6 plus 6 plus 6 in brackets, balls. So when we add here, we shall see that we shall have 18 balls. So if you have been given 3 pictures, yet in mind that you have one picture representing 6 balls, those 3 pictures of a ball would be representing 18 balls. Or we can say one picture is representing 6 balls. How about 3 pictures? We just say 3 times 6 and we shall have 18 balls. And now, given that these are pictures of stones, are equivalent to 20 stones, find the value of one pictograph or find a scale. This one is asking us to find a scale because here, this one is termed as a scale. So now here they are asking us, what is the scale? How many stones are being represented in each picture that we have been given? That is now simply the scale. How do we find scale in pictographs? We shall just say total number that has been given. This is the total now, divided by number of pictures. Number of pictures given. Number of pictures. So the total is 20. And how many pictures are there? We have 1, 2, 3, 4, 5. 5. So what's 20 divided by 5? Can say 20 divided by 5. That is 20 sweets given 5 girls. We shall say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now each one has how many? 4. So this one is showing us that one picture of a stone that you are seeing here, each has 4 stones in it. It's representing 4 stones. That's basically how we can find scale when you've been given a pictograph. We have example number 3. Study the pictograph below showing the number of trees planted in 5 days. The number of trees planted in 5 days. On Monday, how many trees were planted? Here in our pictograph, we've been given 2 pictures of trees. On Tuesday, we have 1, 2, 3, 4. But can you tell us that on Tuesday there were 4 trees planted? No, because there's a scale we are going to look at. On Wednesday, how many? We have 1 picture. On Thursday, we have 1, 2, 3, 4, 5. On Friday, we have 1, 2. But now, we have a scale down here. Remember always, whenever you find such a number, go down here, don't rush. Look down and see, is there anything called scale that you've been given? How many are in each picture? If you've been given trees like this one, how many trees are in each picture? If there are eggs, how many eggs are in each picture? How many sweets are in each picture that you've been given? It depends on what you've been given. So on Monday, before even you look at the questions, you can come here and say, wherever you find 1 picture, right there, 5. So that's 5, 5, 5, 5 trees, 5, 5, 5, 5, 5, 5, 5, 5, 5. So that when you are given a question that how many trees were planted on Wednesday, they'll say 5 trees. How many trees were planted on Monday? They'll say 5 plus 5, that is 10. So basically this is how we can find the number of trees planted on each day. So how many trees were planted on Tuesday and Friday? Get the 5 plus 5 plus 5 plus 5 and then plus 5 plus 5. On Friday they are 10. And then on Tuesday how many are they? 20. And then put them together. So they can even ask you questions like, on which day was the biggest number of trees planted? Or on which day was the highest number of trees planted? Just come here and say, on Friday, there were 2. How about Thursday? I'm seeing there are 5 pictures. How about on Wednesday, 1? So I think on Thursday, this is when the biggest number of trees was planted. So this is basically the pictograph. The first one was a histogram. And then as time goes on, we shall be seeing other graphs that we use when we are representing information or data. Having looked at the different graphs, so we have another one here, line graph. So a line graph, as you see the word line, that one is just made out of lines in different formats. So we have an example here. The line graph below shows the number of bags of sugar sold by 5 traders. 5 traders. So this is a line graph, and down here we have traders. These are names of these traders. We have Bob, Ronnie, we have Dan, John, and Kelvin. This side we have bags of sugar. I told you, down here for these graphs here, we may not need to have a scale, but up here on the vertical, the one which is standing here, we need a scale. And for this matter here, we see that every square or 1 unit is being represented by 2 bags. So now this at 0 is here, this is the starting point. 2, 4, 6, 8, 10, 12, and 14. And now, wherever we find a star, for Bob, this one is showing us that Bob sold 8 bags of sugar, and Ronnie sold 10 bags of sugar, Dan sold 4 bags of sugar, John sold 14 bags of sugar, and then Kelvin sold 10 bags of sugar. So now when you look at this question here, this graph, and after interpreting it properly, go and read the questions. When you read the question, come back to the graph. Question number 1. Who sold the highest number of bags of sugar? They can even give you who sold the biggest number of bags of sugar. Just come here and see who has the highest number. Is it Bob? No. Of course, Ron is up, and then Daniel is down. John, I think, yeah, John is on top of the rest. So it is John. John sold the highest number of bags of sugar. Highest number of bags of what? Of sugar. Period. That's the answer for that number. And then we have number 2, dash and dash sold the same number of bags of sugar. So come here and see. Who are those ones who sold the same? Bob is alone. We got Ronnie. Yeah, we have Ronnie here and Kelvin. They're on the same line. So we shall say Ronnie and Kelvin now sold the same number of bags of sugar. That is it. They look for those ones who sold the same amount. So it cannot be, at times you may be given different items here. So it may not be basically sugar. Number 3, how many bags of sugar did Bob and Ronnie sell all together? This word all together is telling us simply to add. How many bags did Bob sell? We come here and say Bob, how many did he sell? 8 bags. Bob sold 8 bags. And then Ronnie is here, Ronnie sold 10. But how do we put 10? Don't put 10 like this. You'll end up having 90. No. So we follow place values. We shall put a 0 here, and then the 1 here. And we shouldn't forget the addition sign. So 8 plus 0, we shall have 8. Then 1 plus nothing, we shall have 1. And that is now 18 bags. So Bob and Ronnie sold 18 bags all together. So you should now remember, we looked at the histogram, we looked at the line graph, we looked at the pictograph, and as time goes on, we shall be looking at other graphs. And these numbers here, whenever you find them, these are free marks. Just know you have those marks. Read the graph carefully, interpret it, plan, and then read the questions and get back to the graph. You shall see that you get all these answers. So even when you have such a graph, you can come here and say, Bob, where is Bob? Right there, 8. Because has sold 8, and then has sold there 8, sold 8. So we got Ronnie. Ronnie here has 10. Dan 4. John 14. And then Kelvin 10. So that when you have been asked about anyone, you have the number just right there. Other than again looking for the answer when you can't find it.